Sample problem 3.10. Urea is a byproduct of protein metabolism. This waste product is formed in the liver and then filtered from the blood and excreted in the urine by the kidneys. Urea can be synthesized in the laboratory by the combination of ammonia and carbon dioxide according to the equation. So they give you the chemical equation here. It's balanced. 2NH3, gas, right? G means gas, plus CO2, gas, gives you urea. Now, urea has a more complicated formula, right? It's NH2,2CO. It dissolves in water, so that's the AQ. It dissolves in water. It's aqueous, plus liquid water. Okay, so this is a synthesis of urea by using ammonia and carbon dioxide. So in part A, it says calculate the amount of urea that will be produced by the complete reaction of 5.25 moles of ammonia. So here's how we approach it. The relationship between ammonia and urea is a very simple one. It's 2 moles of ammonia for every 1 mole of urea. Every time that you form 1 mole of urea, it takes 2 moles of ammonia to form it. That's what those ratios are telling you there, 2 to 1, right? It's implicit that there's a 1 there. So it's a 2 to 1 ratio. Or we could write it as the reverse, the reciprocal of that. 1 mole of urea for every 2 moles of ammonia. Okay? 1 to 2, 2 to 1. But keep in mind, the ratios are the same. It's just which one's going to the top, which one's going to the bottom. Okay? So now they tell us that there's 5.25 moles of ammonia. In other words, 5.25 moles of ammonia are going to react. So you just ask yourself, okay, if that's how many moles of ammonia react, how many moles of urea are you going to form? Well, here's the ratio. This gives you the relationship between urea and ammonia. So 1 mole of urea for every 2 moles of ammonia, right? It's 1 to 2. So that would give you 2.625. Okay. Now you might argue that's too many sig figs. We got to round it by 1, so 2.63. That's perfectly fine if you want to do that. Okay. So the key to this is to figure out what those coefficients are. Once you got, obviously, if it was not balanced, you need to balance it first. But if it is balanced, you use those coefficients to figure out what's going on. Now it says in part B, determine the stoichiometric amount of carbon dioxide required to react with 5.25 moles of ammonia. That's just big terminology for saying that if 5.25 moles of ammonia reacts, how many moles of carbon dioxide reacts? So what you do there is now we're talking about these two substances, ammonia and carbon dioxide. Again, it's a 2 to 1 ratio. I'm going to write it this way. 1 mole of CO2 for every 2 moles of ammonia. And you could say, yes, it's also, or 2 moles of ammonia for every 1 mole of CO2. They're both correct. But this is the one that we need for this problem because we're interested in carbon dioxide. Part B says determine the stoichiometric amount of CO2. How much CO2 is going to be reacting. So what you do is the same thing we did before. 5.25 moles of ammonia. That's how much of that reacts. And it's 1 mole of CO2 reacts every time 2 moles of ammonia. And you're going to get the same answer we got for part A. It's just we're talking about a different substance. That's how much CO2 reacts. Whereas over here, this is how much urea produced. Okay? So the key to this is the balanced equation. You look for the substance they're interested in. In part A, they wanted to know the amount of urea. So urea divided by, the moles of urea divided by the moles of the substance that was given, which was ammonia. In part B, moles of CO2. How much? That's what they're asking. So therefore, moles of CO2 divided by moles of ammonia using these coefficients in the balanced equation.